All right, let's look at evaluating composite functions with trig functions. So a while back we learned that if you take a function and its inverse and you plug them into each other, normally what you get out of it is just plain old x, because the two things undo each other. But you have to be careful when you're doing this with inverse trig functions, because when we restricted the domain in order to come up with the inverse, it means that we're not always going to be able to just get x out of it. Here's a good example. Let's say you've got inverse sine of 5 pi over 4. 5 pi over 4 is in quadrant, what quadrant is that in? It's in quadrant 3. Yeah, 5 pi over 4. It's in quadrant 3. And so inverse sine, that only gives you stuff out of quadrant 1 and quadrant 4. So you can't just say that the answer is 5 pi over 4. It turns out the answer is going to be negative pi over 4. And there's a couple of ways you can see that. One is just by kind of working through it brute force. If you look at this, sine of 5 pi over 4, that's over here in this quadrant. So down there, sine is negative. ASTC, sine's negative. And the reference angle is pi over 4. And the sine of pi over 4 is root 2 over 2. So you can do that. And now that's a, we can replace this with that. So now this original thing was inverse sine of minus root 2 over 2. So the negative tells us we're in quadrant 4. So it's going to be negative, and which angle has the sine of root 2 over 2? Well, pi over 4. So that's one way you can do it. Another way you could think about this is we're looking at sine of 5 pi over 4. I'm going to draw the sine function. So 5 pi over 4, that's going to be here, roughly, because let's see, it crosses the axis here at pi. Let's see, actually, I guess it's going to be a little further over, because this is pi, this is 3 pi over 2, so 5 pi over 4 is going to be here. So what we're really trying to do is we're trying to go back to between pi over 2 and negative pi over 2. And we're trying to figure out, if we take this and we translate it back, we're really looking for the angle that we get there. And that's going to be minus pi over 4. So we can do these problems either way, by thinking of it graphically or by evaluating the inside and then evaluating the outside function. Let's do some examples. This first one is a little bit weird. Sine inverse of sine of a half. What is sine of a half? I don't know. 1/2 is this is an angle of 1/2 radians. So let's figure out, where is that in terms of the quadrants? This is 0, this is pi over 2, this is pi, 3 pi over 2. Now keep in mind, pi over 2 is like 1.57. So this is a first quadrant angle. If we're in the first quadrant, then we don't have to worry about anything. If we're in the first quadrant, we can just say this is equal to 1/2, and we're good to go. And you can throw that into a calculator too if you want. I'm in radian mode here. Inverse sine of 1/2. I'm putting it in as 0.5, but sure enough, it's going to spit out a 1/2 for us. Now things get trickier when you move into different quadrants. So inverse sine of 2 pi over 3. Turn my computer so I'm actually on screen when I'm leaning over. All right, let's do this both ways. Sine of 2 pi over 3. If I draw that in here, this is pi, so 2/3 of pi is here. The reference angle is pi over 3. Now we're in the second quadrant, and we know ASTC, so sine is positive. And the number for this is going to be positive, and we're looking at pi over 3. Sine of pi over 3 is root 3 over 2. So I can rewrite this as inverse sine of root 3 over 2. And which angle has a sine of root 3 over 2? Pi over 3. If you think about what happened here, we really just sort of took this angle here and we stuck it back into quadrant 1. Or we stuck its reference angle back into quadrant 1. If it had been in a negative quadrant, one where sine is negative, we would have had to stick it back into quadrant 4. But anyway, this is one way to do the problem. The other thing we could do is we could graph sine. And it's important to graph some of the negative. We need to graph everything from minus pi over 2 to pi over 2. And we're looking at this 2 pi over 3. So 2/3, 2 pi over 3 is going to be here. So that's this point right here. And what we're having to do is take this and translate it back in between these two and coming up with this angle. And that angle is pi over 3. How do I know that angle's pi over 3 without having already done all this other stuff? Well, my drawing is kind of bad, but if you look at this distance here, this is pi over 2. We know that this distance would have to be the same as this one. So you could take this difference right here, subtract it from pi over 2 and get that. That's probably not the best way to do the problem. This up here is probably the better way to do most of these. We will see some that are a little tricky where we might want to use this other method. Inverse sine of 7 pi over 6. All right, 7 pi over 6, that's over here, because this is pi, which is 6 pi over 6. So our reference angle here is pi over 6. So sine of 7 pi over 6 is going to be, well, the number is going to be a half because sine of pi over 6 is a half. This is in the third quadrant, making it negative. So this is inverse sine of negative 1/2. All right, 1/2. What angle has a, or which angle has a sine of 1/2? Pi over 6. Which quadrant do we get when we take inverse sine of a negative? We get quadrant 4. So that's going to be minus pi over 6. You know what? Maybe it's worth looking at this on Desmos. If I put this in here, if I just put in sine of x, I'm going to change this over here to give me steps in terms of sorry about that, in terms of pi, gives me this. Tell you what, I'm going to make this into pi over 6 so that it kind of forces it to give me, well, okay, it didn't force anything. But I'm looking at 7 pi over 6. Let me put in x equals. So looking at that, what I'm trying to do now is go back on this graph and find a place over here between -1, between minus pi over 2 and pi over 2 that has the same y-coordinate as this. Now I know that that y-coordinate is minus a half. So I've got it right there. So what I need to do is come back over here and find where else does sine intersect this green line. And it happens right there at negative pi over 6. So that's really what we're doing when we're, moving this back, putting the reference angle into quadrant 4. Let's do the next example. Inverse cosine of 5 pi over 4. All right, so cosine of 5 pi over 4. 5 pi over 4 is down here. Our reference angle is pi over 4. So when I do cosine of 5 pi over 4, cosine's negative in the third quadrant, so this is minus root 2 over 2. And now what I've got to do is say the inverse cosine of minus root 2 over 2. Well, that's going to be in quadrant 2, because remember, cosine, if you take the inverse cosine of a negative value, it gives you an angle in quadrant 2. And it's going to have the same reference angle as this guy over here. So this angle here is 3 pi over 2. And that's my answer. Now, let's do the same sort of thing on Desmos that we did a moment ago. So I'm looking at cosine x, and if we look at 5 pi over 4, what I'm trying to do now is to find something between 0 and, move this over, I'm trying to find something between 0 and pi that has the same y-coordinate as this. So I'm going to put in the line y equals minus root 2 over 2 SQRT 2 over 2. And I'm trying to find the other place where this crosses the axis between 0 and 2 pi. And that happens right here at 3 pi over 4. So my answer is 3 pi over 4. I called this 3 pi over 2, but that is a mistake. 3 pi over 4. All right, this next one. This is one where I really think that we are going to probably want to think about the graph more so than just putting this together. Inverse cosine of cosine of 4. Now that's very much like the thing we just did. It's just, in this case, this is an angle of 4 radians. So 4 radians, where is that? That's going to be over here somewhere. So we're still in quadrant 3. And what we're going to wind up having to do is take this and reflect it back into quadrant 2. So that's 4 radians. And this is pi radians, so that's 3.14. 3 pi over 2 is like 4.71. So let's see, we're going to take whatever this reference angle is here and redraw it into here. So my reference angle in this case is 4 minus pi. And so that's this angle, and it's also this angle here. So the question is, what is this angle here? Well, that angle, the one we're looking for, the one in green, that angle is going to be pi minus the reference angle. Had a spider get on me just now. So pi minus 4 minus pi, that gives me let's see, pi plus 2 pi minus 4. And that's my answer here. Let me write it a little better. So 2 pi minus 4 for this one. And if you wanted to, you could check this on a calculator in radian mode. So let's see. I'm going to put in 2 pi minus 4. And I'm also going to put in inverse cosine of 4. And sure enough, putting this in, it gives me the same answer for both of those. So this is correct. All right, this video is getting long. I'm going to skip the next example, and I'm going to do the last example. Inverse tan of cosine of 4 pi over 3. Okay, we've got different trig functions here. So let's see, cosine of 4 pi over 3. We've just got to do this one from the inside out. Cosine of 4 pi over 3 let's see, 4 pi over 3 gives us a reference angle of pi over 3. So let's see, cosine of pi over 3 is 1/2. And we're in this quadrant, which makes it negative. So what I've got here is inverse tan of negative 1/2. Actually, there's not a nice number for that. So I don't think there's a good way to do this problem and get a nice answer. I'm just going to do inverse tan of 1/2. I think that's pretty much the only way you get an exact answer. But if I put in inverse tan of 1/2, it gives me a 0.46 something. I'm going to double check that on here. Inverse tan of cosine of 4 pi over 3. Yeah, I get negative 0.46. Yeah, I left my negative off. All right, so that's going to wrap this video up. I know it was really long. The next one will be shorter.